Hello everyone, I'm Reza Tangisani, and in this video I'm gonna give you some simple example to learn Python. In this video I'm gonna give you three methods to learn. One of them is using JNL file, the other one is using microfile, and the last one is the using print comment in the Abaqus. Okay, starting with JNL file. This method is very simple, and personally I use this method to learn developing code with Python in Abaqus. For this purpose, we need to create a very simple geometry or something like this. But before starting, we need to go set our directory file. So here set work directory, I change it to another file, as you can see in here, the Python folder. And then I'm gonna create a very simple model. For example, I'm gonna create a part in here. Okay. And after that, I'm gonna assign some material property, for example, density, some random number, it doesn't matter, or elastic. Okay, and then I'm gonna create a section, and then I'm gonna assign it to the part. And then I'm gonna insert it in the assembly and creating a step. Okay, for now it's fine. Then I'm gonna save it. I'm gonna call it example. Okay, and then in my folder I can see a CAE file and JNF file. If you cannot see this extension, you should go to view and then check this box, file name extension. It might be unchecked before, so after checking you're gonna see the extension. Then you need to copy it, and then you need to rename it. For example, example.py. Just you need to change the JNL extension. Changing, you're gonna see this warning, and then you can open it with Notepad++. In here, you can see the code. What is this code? This is the Python code that Abaqus uses for creating the model. For example, if I create another new model and run a script in here, run a script, and then use this Python file, I can see the whole thing that I just created. The material property here, the exact same size for the part, everything. So you can use that code for creating model. For example, if I again create another model, empty model, and then I delete these commands, then in here I again run the Python code, I'm gonna see the part, but for property I can see the name, but I cannot see the material property that I assigned it, or even I cannot see the part in the assembly section. So the thing that's happening is that I deleted this section. So in here I said, okay, we want to create a profile with this size. This is the approximation size, and we created a rectangle with these 2 points. We assigned a depth, and we wanted to be that geometry with this feature. After creating the part, command for Abaqus that it deletes the sketch that we draw. So in here it deleted it, but then we ask it for creating a material with this name. After, there is no comment for assigning the material property. That's why we cannot see the property. So what you can do is, for example, if you want to create a 300 ball or 300 of these parts, like the cuboid or anything else, you can just create these, and then in here you put the for loop, and then you can repeat it for 300 times. Okay, this is the method that you can use from JNL. But the other method that you can use is using the microfile. In microfile, you can, no, I don't want it to empty it. I just wanted to open the same file. Here it is. Okay, I open the CAE file. In CAE file, I mean, because I save it, I can see the material is assigned or other thing. But now I can go to this section and say macro manager. In macro manager, I'm gonna create. Before going, I'm gonna go for load. Okay, I'm gonna to put it in the work directory. Continue. It's a start recording. For here, okay, I wanted to have a concentrated force on this point. So I'm gonna put a value for it, for example 1, and then I'm gonna stop recording. To test the code, I can delete it. Then after run it, you can see it's applied again. So in this case, you can do something in here, and then if you want to do it, for example, 10 times, or do it, I don't know, a few times, you can run it from here. So the thing is happening here is that in your work directory, you can see these two new files, okay? If you open this file, you see this code. This code is a little different from the code that you have it in your JN file. Both of them are Python code, but the way that the software write the code is different from the way that it's write in the JN file. Personally, I prefer the way that's write in JNL file because it's simple, but in here you can see it use more variable. It's kind of good, but honestly I prefer the JNF file. Okay, I want to create micro.2. Continue, and I'm gonna assign a boundary condition in here. After it, I'm gonna stop recording. I want to check the macro file. You see it was macro 1, but after it you can see another new code, macro 2. You can see the new code. So in here, if you want to do the second part of your code, let me do something in here. I'm gonna delete this one, and I'm gonna delete the boundary condition as well. If I run the second one, I'm gonna see this, the boundary condition. But if I run the first one, I can see the load, and here. So you can run it, use the Python, the macro file. But the important part is that you can use the exception. One of the tricky point of it is that if you create a file, for example, in here, and a macro tree, and just rotate 4 times, I think. Stop recording, and then you're gonna see it from here. In macro tree, you can see the 4 times that I rotate my part. It means that even rotating your part, it has the code for it. So, and you can see it in the macro file. So I can say in macro file, you can see most of the codes, but in JNN file, sometimes it hides the code. For example, the rotation of the part. In case you couldn't find your code in JNN file, you should go with the macro file. This is the second method that I wanted to show, but there's another in here. In here, you can use the same method that we use in here for developing the code. In here, we could create a file, and then we do it. We create a model, but we can do the same thing in here. For example, if I erase the part, the model, I can go to this file, and then I can say I want this code, and here the second one, and here, and the third one, and this is the last one, I think. No, it's not. There is one more, which is deleting the sketch. Okay, now I can go to part, and I can see my parts. So we can do line by line in this part in the command section, or we can put it all in the file, in the text file, and then change it. For example, if you want to create, you can just easily say, okay, I want to have a text file, python dot, not, yeah, the python.py. Oh, sorry. In here, I need to erase the txt, the warning, and then you can see an empty file in here. Then you can easily, for example, copy this, but I prefer to go with a JNL, and then you can easily, for example, these function. In here, you always need the function. And then this line, which is creating the material name. Here it is. And then I'm gonna run the code, the Python, and then you can see the property in here. So this is the way that you can use developer code. But there is still one method, which is using this command. In here, for example, if I say print parentheses and mdb.models, in here you can see the name, the result of this. So if I say mdb, this one, it says part 1. I'm gonna make it more specific. I'm gonna say this one, print this one. You can see a lot of commands. Okay, so you can use all these for, I don't know, moving or rotating or what else. I mean, you can use all of. How we can use this? The method is, I mean, the point is, in here you can see, for example, in the first section it says mdb. Mdb is the beginning of the Python code for the CAE file. mdb.model, the name of the model, so it goes to the model 1. So if you have two model 1 and 2, it shows it that it should go to the first one. Constrained sketch profile sheet size. It means that you wanted to create a sketch with this name and this size file, and then it wanted to, in the second one, it goes to a sketch with this name. I wanted to create a rectangle, and the rectangle should start from this point and to the other. As you can see, after each dot you can see a new command. For example, in here you can see it says go to the model 1, go to the material and name it the material 1. So after the model, it means it says you should go to the material section, but in here it says you should go to the part, and then you should, in the part you have a command with a base solid scroll. So after each dot you can have another option. So in here you can say, okay, I'm gonna go to print material part 1. I have these commands, all these commands. For example, you can say model name dot model name. It says the model name is this one. If I just use this one because it's a name, we can have the same thing but with this quotation. Whenever we want to have a code, we can go with this. We can easily dot by dot go and use the other method. But you still need a few codes to start. Okay, for now, for beginners, I have a few notes that you can use. First of all, the loop command. Most easy command for loop is for. So for I in range 1 to 5. To go to loop, we need to have at least one space or one tab. I usually use tab because it's more obvious. And then I say print I. So for now, I'm gonna delete this one, then I'm gonna say want this code. So in here, I'm gonna put it here, and then I'm gonna come use the code Python 1 2 3 4. You can see in here 1 to 5. It means that it doesn't go to the number 5. So this is the one of the easiest code for using the loop. The second code is str, a string. For example, if you want to assign a name, you can say a equals to, let's say, Abba here, and then we want to start it. Okay, we want to run it. So in here, I'm gonna run the code. Then I'm gonna say a is equal to Abba. I want it to be plus stri. So in here, we set tab. In here, the I is changing. So if I ask for print a, I want to see the change. I'm gonna say Python. You can see for the number 1, a abac 1. For 2, abac 2, 3, abac 3, 4, abac 4. And then if I, for example, plus it to us, I can see in here it's running abac 1 us, 2 abac 2 us. Okay, I think it's enough for now. If you needed more example, I have another example for modeling additive manufacturing and welding process. In both models, we need to add material, and for adding material, we need to use Python code for element burst technique, which is very common. Thank you very much for watching this video. I hope you enjoyed this video. If you have any question or if you needed any model, please let us know so we can provide them for you. Until the next video, bye.